Let's move on to page 54 of the ACS organic book here and do problem number 15. With problem number 15 here, we see we have a reaction that's given, and the reaction here, if you notice, this is between a methyl substrate with a fairly good nucleophile. If you had me in class here, this would be in table 2 of base strength, and that replaces the bromine here on the carbon. That is a SN2 reaction that occurs. And of course, just with the methyl group, we cannot have an elimination reaction. Elimination is where we form the double bond. But here with an SN2, this is a SN2 mechanism here, one of the most important. We get a backside attack. Leaving group leaves. There is an inversion of stereochemistry if we have a stereocenter. It's another key fact of that. Now, the rate of the reaction, which is what this is talking about, reaction rate, right here is given by this equation here, where we have rate is proportional to the concentration here of the alkyl halide. If I can spell, which I cannot. And also proportional to the nucleophile. Nucleophile here, again, the definition of that, the root word of that is philos, which in Greek means brotherly love. Here, whatever this is, loves the nucleus. So here, the rate is proportional to both the alkyl halide and the nucleophile. This is a second order reaction then, and what that means is that it depends on both of those. And here this is just some kind of rate constant, some fudge factor. But the key thing is that the concentration or the reaction volume plays a role in this. And so what they say here, what do they say? If you double the volume of the solvent, right here, doubling the volume of the solvent. Okay, if we're in some kind of beaker like this, right here, and they start out right here, when they double it, it's going to be right in here. So what happens to the concentration if you double the volume? Concentration of both of those is going to go down by 1/2. But when you calculate that 1/2 times 1/2, because the concentration is halved by both of those, 1/2 times 1/2, and I probably shouldn't do this here, but it's 1/4. 2 times 2 here on the bottom. So that's a tricky one there. That's actually answer A, not answer B. If you didn't think about it thoroughly enough and actually look at the math that goes into that with this equation here, you would have missed that. Now, let's look at the opposing. Say they asked the opposite thing here. Let's say we had a big tert-butyl group right there. All right, tert-butyl bromide. And we have to add in some water into the reaction, right? Because if you react it with hydroxide, the only thing that's going to occur is an E2, because that base strength is too high for, and this cannot undergo SN2. Remember the order of arrangements there. It follows the speed of the reaction there depends on this substrate here. And this one here, which is the substrate is actually this one right here. This is a tertiary that has the 3 methyl groups on it that cannot undergo SN2 reactions. So we only get an SN1 reaction with that. And here with SN1, this bond is going to spontaneously break off. We form this tertiary carbocation. It's kind of a slow step. Right there, there's a leaving group. Oop, I forgot to show that leaving group on the previous problem. But that one leaves, and then the water attacks the carbocation. This here is called the rate determining step, by the way. Rate determining step means the slowest step in a reaction pathway. Okay, and then we will get this right here, and then bromine comes along and deprotonates that until we get the final, or should I draw it over here, final alcohol right here. And the rate of this reaction here is only dependent on this rate determining step right here. So the rate equation here, if I remember correctly, is only dependent on the alkyl halide. Right here, that was added, the concentration of the alkyl halide. So if we double that volume, that means that the concentration goes down by 1/2 because we're diluting it by twofold right there. And so in this case, if they ask this with an SN1 reaction, what that means is the speed of the reaction would go down by 1/2 right there, instead of 1/4, like in the previous example there. Okay, and that's a little review of SN1, SN2. Let's go on to the next question here very quickly. What we have here is a reaction of an alcohol with acid right here in problem number 16. Let me sketch this out. This is now, remember, the 2002 ACS exam that they converted into a booklet. And they have a lot more condensed structures on this old exam. Okay, so hopefully with the more contemporary ones we do not have that, and there is not as many condensed forms. But anyway, this is an alcohol reacting with H2SO4. Here's the mechanism. This mechanism is going to be an elimination mechanism. Okay, we're doing the opposite. We can make, from alkenes, we can make alcohols, and just the opposite, from alcohols, we can make